The morning of September 18th, 1943, over the skies of Emden, Germany, Oberleutnant Franz Stigler watched his twin 20mm cannon shells strike home against the massive American fighter closing on his formation. Through his Revi gun sight, he saw the impacts, white flashes blooming across the enemy's engine, cowling, tracers walking up the fuselage, hits that should have torn the fighter apart. The American aircraft, larger than any single-engine fighter Stigler had ever encountered, didn't falter. It didn't stream smoke. It didn't break away. Instead, the enormous machine, Americans called it the Thunderbolt, he'd learned. Though Luftwaffe pilots were already using another name, pressed its attack. Its 8 heavy machine guns, sending streams of 50-caliber rounds into his staffel. Stigler broke hard right, his Focke-Wulf 190 cutting through the air as he'd done 1,000 times before. But something in that moment, watching his cannon fire, absorbed by the American fighter as if swallowed by a void, planted a seed of doubt that would grow into certainty over the coming months. The machine that German intelligence had dismissed as too large, too heavy, too brutish to compete with the refined fighters of the Jagdwaffe was proving unkillable. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The question wasn't whether the P-47 could fight by autumn of 1943. That debate had been settled in blood over the Reich. The question was darker, more troubling. How do you kill something that refuses to die? To understand what German pilots confronted in the skies over Europe, one must first understand what they expected. The Luftwaffe fighter force of 1943 was built on a foundation of doctrine, experience, and engineering philosophy that had proven devastatingly effective across 4 years of war. German fighter pilots had cut their teeth against Polish PZL fighters, refined their tactics against French Marines and British Hurricanes, and evolved their approach during the brutal attrition of the Eastern Front and the Mediterranean theatre. They flew aircraft designed around a central principle: performance through efficiency. The Messerschmitt Bf 109 and Focke-Wulf 190 were built to extract maximum speed, climb rate, and maneuverability from airframes kept deliberately light. German engineering, renowned for its precision and elegance, had created fighters that could outturn, outclimb, and in most configurations outgun their opponents. The armament reflected this philosophy. By 1943, standard Luftwaffe fighters carried combinations of 13mm machine guns and 20mm cannons, with some variants mounting 30mm cannon for anti-bomber work. These weapons had been chosen through hard experience. The 20mm Mauser MG 150-120 cannon, firing Minengeschoss explosive shells, could destroy Allied fighters with a handful of hits. A single explosive shell detonating inside an aircraft's structure could shear control cables, ignite fuel systems, or blow away control surfaces. German pilots trained to make these weapons count, learning to close to ranges of 200 meters or less before firing, conserving ammunition for moments when hits were certain. The Rote and Schwarm tactical formations, 2-ship and 4-ship elements, had been refined to create killing opportunities, where a target aircraft, fixated on one attacker, would fly into the guns of his wingman. This system had worked. British Spitfires fell to precise gunnery. Soviet Yaks and Lavochkins, often flown by pilots with minimal training, died in droves. American P-38s, despite their twin engines and heavy armament, proved vulnerable to fighters flown by skilled pilots who understood their limitations. The Luftwaffe had developed an almost scientific approach to air combat, documented in after-action reports, training manuals, and the accumulated knowledge of pilots who'd survived hundreds of sorties. They understood the weak points of every Allied fighter, where fuel tanks were located, how control surfaces could be disabled, which angles of attack exposed vulnerable areas. The art of the fighter pilot, in German doctrine, was the art of the precise kill 1 or 2 bursts, economy of ammunition, maximum lethality. Then came the Thunderbolt. American fighters had been appearing over Europe since late 1942, when P-38 Lightnings first escorted bombers on shallow penetration raids. The Lightnings were respected fast, well-armed, capable of diving away from trouble, but they were also understood. German pilots learned they could outturn the twin-boom American fighter, that its cockpit heating was inadequate at high altitude, that its engines were finicky and prone to failure in the thin, cold air above 20,000 feet. The Lightnings were dangerous when handled by skilled pilots, but they were not mysterious. They fit within the framework of what Luftwaffe pilots expected from enemy fighters. The P-47 Thunderbolt, arriving in numbers over Europe in spring of 1943, defied every category. Intelligence reports delivered to WWII pilots described an aircraft that seemed designed by committee, incorporating every disadvantage a fighter could possess. It weighed 7 tons at combat weight, nearly twice the loaded weight of a Bf-109. It was powered by a single Pratt & Whitney R2 800 double wasp engine, an 18-cylinder radial that produced 2,000 horsepower, but required a turbocharger installation so complex it added another half-ton to the aircraft's weight. To accommodate this massive engine and its associated cooling systems, American designers had created a fuselage as wide as a barrel, earning the aircraft its Luftwaffe nickname, Die Jug, the Jug. Nothing about it suggested aerial grace. German intelligence officers, analyzing gun camera footage and pilot reports from early encounters, predicted the P-47 would be easy prey. Its size would make it unmaneuverable. Its weight would prevent it from climbing with Luftwaffe fighters. Its radial engine, that massive blunt cowling, would be vulnerable to frontal attacks, unlike the inline engines of German fighters protected by their propeller hubs and coolant systems. Some reports suggested the aircraft might serve as a useful ground attack platform, but would struggle in fighter-to-fighter combat. These assessments circulated through ready rooms and briefing huts, shaping expectations. The Jug, pilots were told, was simply another example of American industrial excess, heavy, crude, built in quantities that substituted numbers for quality. The reality revealed itself in fragments through encounters scattered across the spring and summer of 1943 as the 8th Air Force expanded its operations deeper into German-held territory. Lieutenant Heinz Nock, flying with Jagdgeschwader 11, recorded one of the early encounters in his diary. His Staffel had engaged a formation of Thunderbolts escorting B-17 bombers over Bremen in May of 1943. Nock had positioned himself perfectly, diving from altitude to strike a P-47 that had separated from its formation while pursuing a damaged Bf-109. He'd opened fire at 300 meters, watching his cannon shells converge on the American fighter's massive fuselage. The hits were solid, he'd seen them impact, seen the flashes, but the Thunderbolt neither broke up nor caught fire. Instead, the American pilot pulled up hard, the big fighter climbing at an angle Knock had thought impossible for such a heavy machine, then rolled and dove away, accelerating faster than Knock's Messerschmitt could follow. When Knock broke off the engagement and returned to base, his wingman confirmed the hits. Both pilots were certain the American fighter should have gone down. Neither could explain why it hadn't. Similar reports accumulated throughout that summer. A Fokker-Wulf pilot near Hanover put 30 rounds of 20mm explosive ammunition into a P-47 and watched it continue flying straight and level before disappearing into clouds. Another pilot, engaging Thunderbolts over the Ruhr Valley, reported seeing his tracers striking the enemy fighter's wing route, a traditionally fatal impact point, only to see the American aircraft complete its attack run and return to England. Gun camera footage, reviewed at unit headquarters, showed clear evidence of hits, explosive shells detonating against Thunderbolt fuselages, wings, tail assemblies. Aircraft that should have been destroyed continued to fly, fight, and return home. The psychological impact grew slowly, encounter by encounter. Luftwaffe pilots were trained to trust their weapons. When you put cannon shells into an enemy aircraft, that aircraft died. This was cause and effect, as reliable as gravity. But the Thunderbolts were breaking that fundamental rule. They absorbed damage that would have destroyed any other fighter that had destroyed every other fighter German pilots had encountered and kept flying. It wasn't that the P-47s were invulnerable. German pilots did shoot them down, did achieve kills. But the kill required ammunition expenditure that seemed wasteful, prolonged engagements that exposed the attacker to defensive fire from the Thunderbolt's 850 caliber machine guns, or lucky shots that hit critical systems. The reliable, economical kill, the hallmark of German fighter tactics, no longer worked. By August of 1943, as American bomber raids penetrated deeper into Germany and P-47 groups gained experience and confidence, the pattern was undeniable. Pilots returning from missions reported the same phenomenon across different units, different sectors of the front. The Jug could not be reliably shot down with standard tactics and standard ammunition loads. Major Heinz Baer, a veteran with over 100 kills, put it bluntly in a report to his commanders. The American fighter absorbs damage like no other aircraft I have encountered. Pilots must be instructed that destroying a P-47 requires either multiple attacking passes or strikes to specific critical areas: engine, cockpit, or control surfaces. Body hits, even with explosive ammunition, are often insufficient. The question began circulating through Luftwaffe ready rooms. What were the Americans building their fighters from? If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The answer lay in American engineering, philosophy, production capacity, and a fundamentally different approach to fighter design differences that German pilots would come to understand, piece by piece, through bitter experience and, eventually, through direct examination of captured aircraft. The Republic Aviation Corporation, manufacturer of the P-47, had approached fighter design with priorities that inverted traditional assumptions. Where European designers sought to minimize weight, Republic engineers accepted weight as the price of capability. Where German designers refined structures to eliminate every unnecessary gram, Republic built massive, over-engineered airframes capable of absorbing punishment that would obliterate lighter aircraft. The Thunderbolt's fuselage was constructed around a principle that seemed wasteful to German engineers: redundancy. Critical systems, hydraulics, fuel lines, control cables were duplicated or protected by armor. The cockpit sat behind an armored firewall and was surrounded by armor plate totaling nearly 200 pounds. The pilot's seat backed against a piece of armor plate 3/4 of an inch thick. The windscreen was bulletproof glass 2 inches thick. But the true key to the Thunderbolt's survivability lay in its structure itself. The aircraft's fuselage was built like a bridge, with massive longitudinal and lateral members creating a load-bearing framework that could maintain structural integrity even when large sections were damaged. The wing, spanning 40 feet and built around a main spar that could support loads exceeding 12 times the aircraft's gross weight, was designed to flex and absorb impacts rather than shatter. Republic engineers had tested the wing to destruction and found it could withstand stresses that would tear the wings from a Messerschmitt or Focke-Wulf. This wasn't elegant engineering in the European sense, it was brute force structural design, accepting weight penalties to achieve a level of toughness previously unknown in single-engine fighters. The radial engine, that massive Pratt and Whitney double wasp that made the Thunderbolt's nose so distinctively blunt, contributed its own survivability advantages. Unlike the inline engines of German fighters, which required intact coolant systems to function, the radial's 18 cylinders were air-cooled and arranged in 2 rows around the crankshaft. A 20mm shell could destroy 2 or even 3 cylinders, and the engine would continue running on the remaining 15 or 16. The radial's bulk, which German pilots assumed would make it vulnerable, actually provided protection. The engine mass absorbed bullets and shell fragments that might otherwise reach the cockpit or fuel systems. Pilots who'd survived hits that would have killed them in other fighters attributed their survival to the massive engine that sat between them and incoming fire. The fuel system incorporated similar redundancy. The P-47 carried its fuel in self-sealing tanks located in the fuselage behind the cockpit and in the wings. These tanks, developed by American engineers working with British input, consisted of multiple layers: an inner fuel bladder, a layer of vulcanized rubber that would swell and seal when exposed to fuel from bullet holes, and an outer protective cover. When German explosive shells struck these tanks, the result was often holes that sealed themselves within seconds rather than the catastrophic fires that destroyed fighters with unprotected fuel systems. Post-mission inspections of returning Thunderbolts frequently revealed bullet and shell fragment damage to fuel tanks that had sealed successfully enough to allow the aircraft to return to base with minimal fuel loss. German pilots, lacking access to this technical information in 1943, developed theories based on observation and rumor. Some believed the Americans had developed new alloys, materials harder than steel that could resist explosive ammunition. Others speculated about rubber armor, having noticed that Thunderbolts sometimes showed strange elastic deformation around impact points rather than the torn metal characteristic of other aircraft. A few pilots, examining gun camera footage frame by frame, noticed that explosive shells detonating against the Thunderbolt's fuselage seemed to produce less secondary damage than the same shells striking other aircraft, as if the structure was somehow containing or channeling the explosive force away from critical systems. The truth, as some Luftwaffe intelligence officers began to piece together from prisoner interrogations and crashed aircraft examination, was simultaneously simpler and more troubling than exotic materials or secret alloys. The Americans were simply building fighters heavy enough and tough enough to survive hits that killed other aircraft. They were accepting weight penalties, accepting reduced maneuverability and higher wing loading to create fighters that could take punishment and keep fighting. This represented not just a different engineering solution, but a different military philosophy, one that prioritized pilot survival and aircraft recovery over theoretical performance advantages. Major Gerhard Schopfel, commander of Jagdgeschwader 26, articulated the implications in a report written in November of 1943. His unit had been engaging American heavy bomber formations and their escorts for 6 months, accumulating extensive experience against both P-38s and P-47s. Schopfel's analysis was blunt. The American P-47 presents our pilots with a tactical problem not solved by superior piloting skill or better aircraft performance. The enemy has achieved through engineering what we have sought, through pilot training, the ability to survive errors, absorb battle damage, and maintain combat effectiveness. Our pilots report that destroying a P-47 requires 3 to 4 times the ammunition expenditure of destroying a Spitfire or P-38, assuming similar pilot skill levels. This has profound implications for operations, as our fighters carry limited ammunition loads optimized for economical kills. The ammunition problem was indeed becoming critical. A Bf 109 G6, the standard German fighter in late 1943, carried 60 rounds of 30mm ammunition for its centerline motor cannon and 200 rounds per gun for its 13mm cowl machine guns. The Focke-Wulf 190A5 carried 250 rounds per gun for its 4 20mm wing cannons. These loads had been calculated based on combat experience, showing that skilled pilots needed roughly 20 to 30 cannon shells to ensure a kill against typical enemy fighters. But Thunderbolts were not typical enemy fighters. Pilots reported needing to make multiple passes, expending 50, 70, or even 100 cannon shells to bring down a single P-47, if they could bring it down at all before their ammunition ran dry or other American fighters intervened. This ammunition calculus created tactical dilemmas. A Luftwaffe fighter pilot intercepting a bomber formation now faced a choice: engage the heavily armed and tough B-17s and B-24s with their formation's defensive fire, or engage the escorting Thunderbolts that were equally difficult to destroy and actively hunt German fighters. Either choice required extensive ammunition expenditure. Pilots who'd successfully destroyed a Thunderbolt often found themselves unable to engage bombers, having burned through their ammunition load in the fighter engagement. Conversely, pilots who saved their ammunition for the bombers found themselves vulnerable to Thunderbolt attacks during their bomber runs. The winter of 1943 brought increased urgency to understanding the Thunderbolt phenomenon. As American bomber raids intensified and P-47 groups extended their range with external fuel tanks, German fighter units began compiling systematic documentation of their encounters. What emerged from these reports was a portrait of an aircraft that violated fundamental assumptions about fighter vulnerability. Hauptmann Johannes Steinhoff, flying with Jagdgeschwader 77, recorded a characteristic encounter in his combat log from December 19, 1943. His Staffel had intercepted a formation of B-17 bombers near Bremen, approaching from high altitude with the sun behind them, textbook positioning. As Steinhoff prepared his attack run, 4 P-47s dove from above, having apparently spotted the German fighters despite the intended surprise. Steinhoff's wingman engaged the lead Thunderbolt, putting a solid burst of 20mm cannon fire into the American fighter's wing root and engine cowling. The P-47 rolled inverted, trailing what appeared to be smoke, and dove away. Both German pilots assumed the kill was certain, but as they turned back toward the bombers, both Thunderbolts reappeared, climbing from below, their 8 machine guns firing. Steinhoff's wingman took hits and had to break off, eventually making an emergency landing with his Fokker-Wulf's coolant system destroyed. The Thunderbolt they'd killed minutes earlier was, Steinhoff wrote, not only alive but apparently undamaged and eager to continue the fight. Such incidents accumulated into a psychological burden. Luftwaffe pilots had been trained to trust their situational awareness, to mentally track damaged enemy aircraft as they left the combat area, confident those aircraft were out of the fight. Thunderbolts broke this trust. Aircraft that appeared destroyed returned to attack. Aircraft that should have been crippled maintained full combat capability. The mental accounting that allowed pilots to manage the chaos of air combat that fighter is damaged, and leaving, those two are still threats, that one is smoking, and finished no longer worked reliably when Thunderbolts were involved. Every P-47 had to be treated as a threat until it was literally falling from the sky in pieces, and even then, some pilots reported, there was doubt. The physical evidence told the story that words struggled to convey. Luftwaffe maintenance crews, examining their own damaged fighters that had survived encounters with Thunderbolts, found themselves facing a new category of damage. The Americans' 50 caliber machine guns, 8 of them firing in concert from the Thunderbolt's wings, created destruction patterns unlike anything seen from rifle-caliber weapons. A single 50 caliber round, weighing nearly 2 ounces and travelling at over 2,700 feet per second, could punch through the relatively light structures of German fighters and continue through multiple bulkheads or components. When 8 of these weapons focused on a single target, the effect was devastating. German aircraft that survived Thunderbolt attacks often required extensive rebuilding, their airframes riddled with holes the size of a man's fist, control surfaces shredded, structural members cracked or severed. Yet the Thunderbolts themselves, when they went down and could be examined, revealed the inverse situation. Luftwaffe technical officers inspecting crashed P-47s found aircraft with dozens of bullet and shell holes, evidence of multiple hits from machine gun and cannon fire that had nonetheless flown for miles before going down, sometimes making controlled crash landings rather than falling from the sky. One technical report from January 1944 described a P-47 that had crashed near Osnabrück with 17 separate 20mm cannon hits documented in its structure. The aircraft had maintained controlled flight until fuel exhaustion forced the pilot to belly land in a field. The pilot, captured uninjured, reported he'd been unaware of the extent of the damage until after landing. This technical intelligence began reaching higher commands, where it prompted increasingly uncomfortable questions. If the Americans could build fighters this tough with their current technology and industrial capacity, what would future American fighters look like? If a relatively early war design like the P-47 could absorb damage that destroyed German fighters, what would happen when America's industrial base reached full wartime production and began producing newer designs? The implications reached beyond individual air combat tactics into strategic considerations about Germany's ability to maintain air superiority over its own territory. Oberstleutnant Hannes Trautloft, a veteran fighter leader with extensive command experience, addressed these concerns in a detailed memorandum to Reichsmarschall Göring's headquarters in February 1944. Trautloft's analysis was methodical and damning. He noted that German fighters had been designed during a period when air combat occurred at lower altitudes, when engagement times were longer, and when the enemy consisted primarily of European designs optimized for similar performance envelopes. The P-47 represented a paradigm shift, an aircraft designed from the beginning for high-altitude combat, for brief but intense engagements, and for survival above performance. "We have yohua our fighters to kill efficiently," Trautloft wrote. "The Americans have optimized theirs to survive and return. In a war of attrition, survival matters more than elegance." The attrition mathematics were indeed becoming stark. By spring of 1944, as Allied invasion preparations intensified and American bomber raids reached unprecedented scale, Luftwaffe fighter units were losing experienced pilots at rates that could not be replaced. Some losses came from direct combat, but increasingly, losses resulted from accumulated stress, from pilots killed or injured in crashes returning to base with damaged aircraft, from combat fatigue eroding the judgment that kept pilots alive. The Thunderbolt contributed to all these factors. Engaging P-47s required extended combat that burned fuel and ammunition, increased stress, and kept pilots in harm's way longer than engagements against other fighters. Damaged German fighters, attempting to disengage from Thunderbolts, found themselves pursued by American fighters that could maintain high speed in dives and had the fuel capacity to chase crippled prey across hundreds of miles of territory. Lieutenant Heinz Nock, whose early encounter with Thunderbolts over Bremen had first alerted him to the aircraft's unusual survivability, recorded a moment of recognition in his diary in March 1944. He'd just returned from a mission where his Staffel had engaged both P-47s and Spitfires over France. The Spitfires, he noted, were more maneuverable, could outturn German fighters in sustained engagements, and were flown by skilled pilots. But when his guns damaged a Spitfire, it went down the traditional equation held. The Thunderbolts, conversely, simply refuse to acknowledge when they've been beaten. You put shells into them that should be fatal, and they continue as if nothing happened. The psychological effect is worse than the tactical problem. You begin to doubt your own shooting, your own eyes, your own judgment. This psychological dimension, the erosion of confidence in one's own effectiveness, may have been the Thunderbolt's most significant impact on Luftwaffe fighter operations. German pilots had entered the war with absolute confidence in their aircraft, their training, and their weapons. That confidence had been earned through victories against Polish, French, British, and Soviet opponents. But the American approach to air combat, embodied in aircraft like the Thunderbolt, was undermining that confidence through attrition and uncertainty. You could not trust that a damaged Thunderbolt was actually damaged. You could not assume your cannon hits would produce the expected results. You could not plan ammunition loads and engagement tactics based on the reliable equations that had worked for 4 years of war. The technical countermeasures, when they came, reflected both German engineering sophistication and increasing desperation. By mid-1944, Luftwaffe fighters began receiving heavier armament, specifically to counter the American bombers and their tough escorts. The 30mm Mk-108 cannon, firing a shell weighing nearly a pound with enough explosive to destroy a bomber with a single hit, began appearing in Messerschmitt and Focke-Wulf fighters. These weapons could damage even Thunderbolts catastrophically when they hit, but the heavy cannon had severe drawbacks: low muzzle velocity that made aiming difficult, tremendous recoil that destabilized the firing platform, and even more limited ammunition loads than the 20mm weapons they replaced. A Bf-109 G6, mounting the Mk-108, carried only 60 rounds, enough for perhaps 3 or 4 bursts. Missing was not an option, yet the American fighters were small targets moving at high speed, and combat occurred in 3 dimensions with constantly changing angles and ranges. Some units experimented with R-4M rockets, unguided projectiles fired in salvos of 12 or 24 from racks beneath the fighters' wings. These weapons, developed for anti-bomber work, could theoretically damage even a Thunderbolt if they connected. But they were unguided, effective only at close range, and their launch created drag and weight penalties that made German fighters more vulnerable during the approach. More fundamentally, they represented an admission of defeat, an acknowledgement that conventional cannon armament was insufficient against American engineering. The intelligence picture became clearer as the war progressed, and more complete information about American aircraft production reached German analysts. The numbers were staggering and deeply troubling. Republic Aviation's factory in Farmingdale, New York, was producing Thunderbolts at a rate exceeding 300 per month by late 1943. Additional production lines had been established at Evansville, Indiana, where Ford Motor Company applied automotive mass production techniques to aircraft manufacturing. By mid-1944, combined P-47 production approached 1,000 aircraft per month. These weren't hand-built fighters crafted by skilled technicians, but mass-produced machines rolling off assembly lines at rates that German factories, under constant Allied bombing and resource constraints, could not hope to match. Moreover, the Americans were continuing to improve the design. The P-47D model, appearing over Europe in early 1944, featured additional fuel capacity that extended range to the point where Thunderbolts could escort bombers to Berlin and beyond. Later variants mounted even heavier armament, upgraded engines producing 2,300 horsepower, and additional armor. Each improvement made an already tough aircraft tougher, an already capable fighter more capable. German intelligence officers, analyzing this trajectory, recognized they were facing an opponent whose industrial capacity could not only replace losses, but continuously improve its equipment even as production rates increased. The contrast with German fighter production was stark and demoralizing. Messerschmitt and Focke-Wulf factories, despite heroic efforts by workers and management, were producing fighters at roughly 1/4 the American rate. Worse, Allied bombing campaigns specifically targeted aircraft production facilities, engine factories, and fuel production plants. German fighters were becoming more sophisticated: the Ta-152, the Me-262 jet fighter, but also more complex and slower to build. The elegant engineering that had characterized German fighter design was becoming a liability when facing an enemy who could accept weight and complexity penalties, because they had the industrial capacity to build heavy, complex aircraft in massive quantities. Pilots who survived to the war's end and later wrote memoirs uniformly acknowledged the P-47's impact on Luftwaffe operations. Günter Rall, Germany's third highest-scoring ace with 275 victories, noted in his post-war writings that the Thunderbolt represented American industrial might in aerial form. "We could shoot them down, I did, several times, but there were always more, and they could absorb damage that would destroy our aircraft. The equation was unsustainable." Johannes Steinhoff, who survived the war to command post-war German air forces, was more blunt. "The Thunderbolt taught us we had already lost. Not any single battle or engagement, but the war itself. When your enemy can build fighters you cannot reliably kill, in quantities you cannot match, and fly them with pilots who learn and improve while yours die. The mathematics are clear. The final accounting of the Thunderbolt's combat record supports these assessments. The P-47 achieved an overall kill-to-loss ratio of nearly 5-to-1 in air combat, 3,752 enemy aircraft destroyed against 824 Thunderbolts lost in air-to-air combat. But these numbers don't capture the full impact. They don't measure the missions that succeeded because Thunderbolt escorts prevented Luftwaffe interception. They don't count the German fighters that broke off attacks because Thunderbolts appeared, or the bomber crews who survived because their escorts could keep German fighters at bay. They don't quantify the psychological burden imposed on Luftwaffe pilots forced to engage an enemy they knew could absorb damage that would kill them if the situation were reversed. More tellingly, the numbers don't reflect the aircraft that returned to base. The 8th Air Force's statistical analysis showed that Thunderbolts had the highest survival rate of any Allied fighter in Europe. Aircraft that would have been write-offs in other airframes were repaired and returned to service. Pilots who would have died in lighter fighters survived to fly another mission. The war-winning equation wasn't just about destroying enemy aircraft, it was about preserving your own assets, maintaining your pilot strength, keeping your combat power intact through hundreds of missions across years of warfare. By war's end, Republic Aviation had produced 15,686 Thunderbolts, making it the most produced American fighter of World War II. These aircraft had flown escort missions deep into Germany, ground attack missions in Western Europe and the Pacific, and fighter sweeps that dominated the skies over the Reich in the war's final year. They had proven that the American approach to fighter design, accepting weight for survivability, prioritizing pilot protection, building in redundancy and toughness was not just viable, but superior for the sustained air warfare that characterized the European theater. The Germans had built beautiful fighters, elegant machines that pushed the boundaries of aerodynamic and engineering efficiency. They had trained superb pilots and developed sophisticated tactics, but they had confronted an opponent who didn't compete on the same terms, who accepted that fighters would be hit and designed them to keep flying anyway, who recognized that wars are won not by individual combats, but by cumulative resource advantage sustained across years of conflict. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.